All right, so thank you. Before we dive into our specific request, I'm going to quickly give you some background from about 30,000 feet. And for the past 15 years, we have focused primarily on land development. And our typical development is about 300 to 400 either single family homes or apartments. And so, as part of our quote unquote land development, we get both the land use approvals, so you can think of as kind of a custom zoning. And importantly, we solve everything else that needs to be solved for a vertical developer to start. And so that might be an access issue, a boundary issue, an easement issue. And so we get the land use approvals or the government's ability to build the specific use, and we solve or quantify all outstanding uncertainties before passing the baton to a vertical developer. And we pride ourselves on making our projects turnkey for the vertical developers so that there's no uncertainty or no outstanding issues. And this was a project about 300 apartments, and it was being built or is located in an area that has very high local trade expenses. And so as part of our goal to provide a turnkey development to the vertical developer and resolve or quantify any outstanding issues, we tried to attempt to give the prospective vertical developers a reasonable cost approximation of what it would cost to vertically develop these 300 plus or minus apartments, so that the vertical developers were not scared by the local horror stories of just a wide range of costs. And as part of that experience, we traveled up to Boise, Idaho, and met with and toured the Guerdon factory, and they build what are called volumetric modular units. And you can think of kind of a Lego, an apartment complex or a house being constructed of essentially Legos, and they're trucked to the site where they're craned into place and then stitched together. And that stitching can include drywall seaming, connections of the MEP. And so importantly, the modules are completed. They'll have the carpet installed, the flooring, drywall, lighting, everything is done. Now, we won't be putting furniture in, but at times, like for example, hotels, they do that. And so that experience whetted our appetite for potentially expanding beyond just the land development to possibly build our projects vertically also using this volumetric modular construction. And so that brings us to what we're calling our snowmass exercise, which is an atypical development for us in that it's just one single family residence. But we feel like it's a good guinea pig or test to further explore the volumetric modular for a handful of reasons. First, it's on a very small scale. Second, while this property is just much smaller than what we would typically do, the site is very constrained, and so the house has been designed to accommodate those site constraints, and the design of the house will stress or push what we can practically do, which is our first goal of the snowmass exercise, is what we want to do practically feasible. I would say second, and probably most critical, are the costs and or timing savings real, and what are the extent of those savings? And then third is our ability to duplicate the scrappy team of folks that we've assembled for our land development business that primarily consists of various different consultants and freelancers such as yourself. And in our land development business, we take it 90% of the way, plus or minus, before engaging the local professionals. And we work together project after project, and we're fairly efficient, both in terms of time and money. And that is largely out of necessity because our land development projects, about 1 out of every 4 projects, is a complete waste or loss of all the time and money that went into it because the local government authority rejects our plan. And so for that reason, we have to be pretty scrappy and cost efficient, knowing that some of our projects will be a complete loss. And so one of the additional goals of what we're calling our snowmass exercise, in addition to assessing the practical feasibility, what you can do and can't do with modular, and the cost and time savings, are they real and how much, are we able to duplicate the land development team, but for the vertical module development. All right, so those are our goals for the snowmass exercise. Let's talk about the actual snowmass exercise. So on the left is a rendering of this house, and this house was designed to be built traditionally or on site. And so on the left is the rendering of what we're calling the traditionally or on-site build, and these are the corresponding floor plans. And so this was designed knowing that we might flip or try to flip it to modular, and so we took some of those into consideration. Some of the modular requirements were taken into consideration in the design of the traditional or site-built home and the corresponding floor plans, and we have since taken these floor plans and modified these, the original traditional site-built floor plans, to these, which are the current modular floor plans. And there's some telltale signs about the modular, and that, where the modulars come together, there are mated or paired walls. The shipping widths were taken into consideration. This is obviously 2D, but the shipping heights were also taken into consideration. And so this is the on-site traditional build, and this is the modular build. And side note, we think that this house is better looking than this house, but we'll work on, if we proceed to build this modularly, depending on the outcome of our exercise, we'll redo these renderings to make them look a little better, largely with materials. And that brings us to one of the other comments, which is that good enough is really good. And that for our exercise, because again, we don't know whether this will get built, whether it's going to get built modularly or traditionally or not at all, solely for purposes of the current exercise, we just need to get it reasonably close. And we think that's probably 90% of the final plans, but we want it to be 90% or more, reasonably close, because if we don't, we won't get an accurate cost sense of the cost savings and whether that is real or not. But importantly, for your purposes, we don't need any stamp or certification for our current exercise. And then if we proceed after we're done with the exercise to build this modularly, that's where we'll engage the local professionals to take it the remaining 10%. As previously discussed, we're contemplating building the house in modules, volumetric modules. The modules would be trucked in, craned in place, and then stitched together. And this is the first level, and we'd have 1, 2, 3, 4, 5 modules on the first level. The garage would be built on site. Then we go upstairs to the second level where we have our 6th, 7th, and 8th modules. And then this is the basement. This is downstairs. This is all being built on site. It is foundation. So this is the basement. It'll be concrete cast in place, poured in place, and then a corresponding crawl space, concrete foundation walls, slab on grade floor. To give you context, this is module 1 above. All right, so let's try to clarify the requested scope. And these are the MEP items that we do not need. We don't need fire suppression. It is not required if the house is below 5,000 square feet. The house is currently below 5,000 square feet. We do not need fire suppression. We also do not need air conditioning. It is a cool climate. We also do not need heat, as we are planning to use the warm board system, which is a radiant heat system, and we will have these boards essentially custom designed. And then Warm Board also supplies the tubing and the boiler and all the other different stuff needed. So it's largely self-contained and plug and played. So we do not need any of these. We do need a plumbing plan and an electrical plan, but we do not need a stamp or certification at this point. We may not need a stamp or certification because we may not build the house modularly. This is largely a educational exercise, so no stamp or certification is required at this point. Now, I understand that there has been some confusion, and we accept responsibility for thinking you can, the modules versus the whole house considerations, what we're calling the whole house considerations. All right, so here again is the basement. In the basement is a mechanical room, which will house the electrical panel, the main water shutoff, the water filter, the boiler, all of that different stuff. And for our purposes, you can assume for the plumbing that the source of the water is an existing well on site. And so here's the site plan, and this is essentially that footprint that we've been looking at. And the well is here. And so for our purposes, you can kind of assume that the well is over here, and the water will be trenched into the mechanical room. And that well is already on site. There's a pump in it. It's producing, I think, 15 gallons a minute. There's also an existing on-site wastewater treatment system, which is also a fancy way of saying septic system, and that is down here. So for our purposes, you can assume that all of the wastewater will be from the various different modules will be directed to the mechanical room, and then there will be a line run from a wastewater line run from the mechanical room to the septic system, or OWTS, on-site wastewater treatment system. All right, similarly with electrical, there is on-site phase one, essentially right here. So for our purposes, you can assume that the electrical will be brought to the mechanical room from the existing transformer that is over here. All of this on-site work, including the various different equipment in the mechanical room, is what we're referring to as the whole house considerations. We will tackle that at some point. That is beyond the scope of our first request, which is just for this module 1, and specifically a plumbing plan and electrical plan for module 1 here, which is the master bedroom, bath, and closet. And for all the main level modules, so 1, 2, 3, 4, and 5, you can assume that the MEP, specifically the plumbing and the electrical, will be brought down below the module and centralized in the crawl space, which is generally right around here. The water supply will need to be in the cavity of the various different modules, because otherwise it would freeze. So you can assume that the water supply for the first level modules will essentially be in the floor of module 1, 2, 3, 4, and 5. And then the second level modules, the MEP, so this is the first level, which will all flow through to the crawl space, again, except for the water supply, which will be in the floors where there's insulation. The second level, all of the MEP will be directed to a centralized chase. So the MEP will flow through in the floor of the module, the various modules 6, 7, and 8, to a centralized chase, probably in the walk-in closet of this room, where it will flow down, or the chase will be directed down to the first level, probably somewhere in the pantry, and ultimately down to the mechanical room. But for purposes of our request number 1, which again is just this module 1A and B, 1A being the bottom and 1B being the top, this module here, which is what we're calling the master bed, bath, and closet, which sits above the crawl space below right here, your whole house considerations can be general assumptions. So you don't necessarily need to design right now the electrical panel. We don't need to design the water shutoff, the filter, the boiler. And specifically for this module 1A, which is the bottom, and 1B, which is the top, the plumbing plan needs to have one toilet rough end plumbing. So I'm sure there is standardized rough end plumbings that you can take out of a library and put in a Revit model for the toilet, similar with the 2 sinks or vanities, and 1 tub and 1 shower. And you can assume the water supplies for these are coming through the floors of the adjacent modules 2 and 3 from the mechanical room, which is below, essentially right here. But for purposes of just our module 1A, you can just show the supply lines essentially terminating at the edge of the module 1. And with respect to the wastewater, you can show it being centralized essentially at one location below the module in the crawl space. All right, moving on to the electrical for module 1A and B. And recall, for shipping height purposes, the dividing line between module 1A below and 1B, the roof above, is this red line here. And so the electrical plan, there will be bedroom ceiling cans. So, kind of 1 row here and 1 row here. We're happy to design these, and then you can do the MEP or you can do it yourself, but it doesn't need to be overly sophisticated. There will be bedroom switches near the entry, so generally right here, and those switches will control the bedroom cans and the bathroom cans. Then there will be bedroom plugs, probably 1 on either side of the fireplace, 1 on either side of the bed, and possibly 1 right here. Then going in the bathroom, we'll have ceiling cans. And then above the sinks will be vanity light bars. There will be a switch right here that controls the bathroom cans and also the closet cans. There will be switches adjacent to the vanities here and here that will control the vanity light bars. Then there will also be a switch right here or right here going into the toilet to control the toilet can lights. And then there will be a switch, let's say right here, that will control the cans in the closet. and then we'll have ceiling cans in the closet. With respect to connecting the bottom A and the top B, the roof, or this section here with this section here, we can have a conduit in one centralized location where all of the electrical wires are directed for the bottom to connect to the top, and I would suggest doing it here or here. And then in terms of the whole house consideration, you can assume that there'll be electrical conduit in the crawl space back to the mechanical room. All right, hopefully this helped clarifies the scope, and once we get done with module 1, then we'll proceed to the remaining 7 modules and the whole house considerations. Thank you.